In number 81 here, they've given you a function here that tells you the depth of water in a rain gauge is increasing at a rate, given by this function right here. So the important thing here, guys, is that this is a rate function, most similar to a velocity. And you'll notice here the units here, that R of t function is being measured in centimeters per hour. And they want to know how much the depth of the water in the rain gauge increased from 0 to 3 hours. So they've given you a centimeters per hour function, and they're asking for an answer then. You can see from the units in all four choices here, they're asking for an answer in centimeters. So it's kind of like they gave you a velocity function and they're asking a question about position. So what are we going to do? We're going to do the definite integral of that R of t function right there. And in fact, I'm just going to go ahead and write it right here as R of t. We don't need to take the time to actually write down what it is. We'll do that in our calculator in a second. And we want the definite integral of this rate function from 0 to 3. And what that's going to do here, guys, is get us something akin to displacement, basically the change in the amount of rain that's in that rain gauge from 0 to 3 hours. So this is going to be a pretty easy one to type into the calculator once we've figured out what it is that's going on here. So let's see, this guy right here. All right, and let's go back to our calculator page, and here we go. So we're going to do a definite integral. That's menu 43 for you guys, and an integral from 0 up to 3 of this kind of messy function. So let me go back and forth a couple times here. 0.5 plus t cosine, and then a whole bunch of junk. All right, 0.5 plus, we had a t, you know what, I'm just going to put that in as an x, multiplied by the cosine, and then we had an ugly angle we were taking the cosine of here, pi. I'll make that x squared over 80. All right, gotcha. So here's our fraction right here, and we've got a pi, and that gets multiplied now by, that'll be x cubed, and then all over 80 on the bottom. And since I used x here, we are integrating with respect to x. Okay, and I'll hit enter, and we should get our answer here of 4006. So that would round to 5.401. Right there, 5.401, got it. And that means that D should be our correct answer for problem number 81.